Hello, good evening everyone. The last class is starting. That is our second unit, electric potential and capacitance of a capacitor. First of all, what is the basic meaning of electric potential? The electric potential means the work done acting in positive charge. The work done acting in positive charge is called electric potential. That is a certain distance from the distance of infinity to the against infinity to the point against the electric field line. It means simply says that the electric potential means the work done acting in positive charge is called electric potential. The unit of a electric potential is, that is a standard SI unit is volts. The standard SI unit of a electric potential is volts, and the unit of work done is joule. The unit of charge is coulomb inverse. Joule coulomb inverse. That is the concept of electric potential. And what is the electric difference? The potential difference. The potential between the any two points. That is the electric field line. Potential difference of a first position. Potential difference of a second position. That is VB. What is this? That is small displacement is called the dx is called displacement. The potential difference means the electric potential difference between the 2 points in the electric field line. The electric potential difference between the 2 points in the electric field line. The work done is acting for a positive charge from the one point to another point. That is called potential difference. Then that is a potential difference means the difference of a potential difference of a initial position to, that is a VB, final position is VA. That is a potential difference. And how to calculate electric potential due to the single point charge? Derive, that means derive the electric potential due to isolated point charge. Derive the electric potential due to the isolated. That means isolated means there is single point charge. First, to draw the electric field line. This is called electric field line. The electric field line E is the electric field line. Certain distance of a electric field line is, that is infinity. Final distance is infinity. And O is the point. That is a single point charge is Q. The single point charge Q is acting at a point O. And P is also point. The small r is called distance between the P and O. Small r is the distance between P and O. And the potential difference means the difference of any two points, that is A, position A and position B. What is the difference between any two points is, that is called small displacement is dx. It one end to other end and other end to one end. That is a displacement is, that is a negative of a dx minus dx. And that is x is the distance between, x is assumed that x is the distance of A and O. The distance of A and O. When a charge is taken as, the Q1 can be taken as, that is a 1 coulomb of a charge. Q2 is taken as Q. And assume that the 1 coulomb of a charge is, that is a 1 coulomb of a charge, that is Q1. The charge Q2 is Q. That is Q. That is the diagram and explanation of a electric potential due to the single point charge. Consider in the diagram shows the Q is the point charge or isolated charge is placed at a point O in a free space. And X is the distance between A and O. X is the distance between A and O. That is A is called, that is a first charge, that is taken as charge is 1 coulomb of a charge. And P is a point at a distance R from O. P is a point at a distance is R from O, and E is called electric field line. E is a electric field line due to the charge plus Q. And the 1 coulomb of a charge, that is Q1, it is acting at a point A. The another coulomb of a charge is, that is Q2, that is taken as, assume that is Q. And A and B be the two different points separated by a small displacement is, that is a dx. Small displacement is, that is taken as, assume that is dx. Then first by using a from Coulomb's law, from the Coulomb's law, what is the statement? The Coulomb's law states that it is a directly proportional to product of charges and inversely proportional to square of distance between them. That is, F is equal to constant 1 by 4 phi epsilon naught the product of charges Q1 Q2 divided by square of distance between them. That is called equation number 1. When assumed that the Q1 is the 1 coulomb of a charge and Q2 is the Q coulomb of a charge. That is, a small displacement is, it is taken as x. That is, x can be replaced by small x. If assume that Q2 is equal to Q, Q1 is equal to 1 coulomb, and the distance is R is equal to x. That is, small r is replaced to x. This is assuming this value is substituted in equation number 1. Therefore, the Coulomb force must be is equal to constant is as it is. The constant is as it is. That is 1 by 4 phi epsilon naught. That is, Q1 means that is a 1 coulomb. Q2 means that is Q. X is x square. That is called equation. Or one more step is, that is 1 by 4 phi epsilon naught Q by x square. That is the equation number 2. Equation number 2. Then what is the work done? The small work done. By using a definition of work done, the work done means force into displacement. The small work done dW, the small work done is dW in a moving a 1 coulomb of a charge from A to B. The small work done is the small work done of a moving a 1 coulomb of a charge is, the 1 coulomb of a charge is from the points A to B. What is the work done? That is, work done means force into displacement. Therefore, the small work done is dW. The small work done is dW is equal to F into, that is the force into the displacement is A to B. That is, A to B is, that is the negative of a dx minus dx. That is called equation number 3. Equation number 3. Substitute the equations. Substitute the equation, that is 2 in 3. Equation 2 is substitute. Equation number 3 we get the small work done is dW is equal to minus of, that is the equation number 2 is called force, Coulomb force. What is the value? That is 1 by 4 phi epsilon naught Q by x square. That is 1 by 4 phi epsilon naught Q by x square into with respect to dx. That is the small work done moving A. This equation is called the small work done moving A, the 1 coulomb of a charge from, that is A to B, that is finally, that is dW is equal to minus 1 by 4 phi epsilon naught Q by x square with respect to dx, where the negative sign indicates that the work done is, the work done dW, the work done is opposite to the direction of the electric field line. Now that means the electric field line is opposite to displacement, both are same. Then find out the total work done. The total work done moving a 1 coulomb of a charge from the distance is infinity to the final distance is infinity. The initial distance is small r, that is infinity to small r. The total work done dW moving a 1 coulomb of a charge is 1 coulomb of a charge from the distance infinity to r. It is written as, therefore the total work done means it is taken as, that is capital W. Capital W is the total work done The total means by using a summation or integral, distance is lower, there is a final distance is infinity, initial distance is small r, upper limit is r, lower limit is infinity, that is small dw. Or the integral of infinity to small r, substitute the value of dw. What is the dw? That is the dw value is minus 1 by 4 phi epsilon naught. Substitute bracket open, minus 1 by 4 phi epsilon naught, that is q by x square with respect to dx. Therefore, the total work done is equal to, that is sign is take outside, constant 1 by 4 phi epsilon naught, q is a scalar quantity, the charge and constant is take outside. That is the integration rule, sign and constants, that is take outside, q by 4 phi epsilon naught, the integral infinity to r, the 1 by x square dx. Okay now, therefore the total work done is equal to minus q by 4 phi epsilon naught, that is the standard formula. The integral of 1 by x square is, that is a minus 1 by x. By using a integral of x power n, that is x power n plus 1 by n plus 1. This is the formula. The standard results of the integral of 1 by x square is minus 1 by x. Substitute the value. That is the integral of 1 by x square with respect to dx is minus 1 by x. Upper limit is smaller, lower limit is infinity. That is minus into minus is plus 1 by or q by 4 phi epsilon naught, bracket open, minus into minus is plus, replaced by x is a function, it is x is replaced to upper limit, x is replaced to lower limit, that is 1 by r minus 1 by infinity. The 1 by infinity value is, that is 0, that is the work done is equal to 1 by 4 phi epsilon naught, that is the charge is q, the distance is r. The work done stored in a potential difference, that means w is equal to v. Therefore, the potential difference v is equal to 1 by 4 phi epsilon naught, 1 by 4 phi epsilon naught q by r. V is equal to 1 by 4 phi epsilon naught q by r. This equation is called expression for electric potential due to the single point charge, isolated point charge, both are same. V is equal to electric potential. V is a electric potential and Q naught is a permittivity of free space. Q is a charge. Q is a single point charge or isolated point charge. Small r is the distance between P and single point charge at a point P and single point charge. That is the concept of electric potential due to the isolated point charge. Next concept is superposition principle. Superposition principle. What is the statement of superposition principle? Any physical quantity, that is a charge, electric field, magnetic field, velocity and linear momentum, any physical quantity. That means in the system of the total of a net physical quantity must be is equal to sum of the individual physical quantities. That means by using in this concept is in this chapter is the study of electric potential by using the V value. The V means the V is the electric potential. The system is consisting in the presence of electric potential. That is the electric potential means that is a V is equal to the electric potential means work done for unit positive charge. By using a electric potential, what is the statement of superposition principle? The superposition principle states and based on electric potential means the total electric potential of a system. The total resultant or net electric potential of a system must be is equal to sum of the individual potentials, that is Vn. Vn is the nth term of a electric potential. That means the total electric potential must be is equal to the algebraic or the sum of the individual electric potential, sum of the individual electric potentials. That is the superposition principle. Calculate the, my question is calculate the electric potential. Calculate the electric potential by using a superposition principle. How to calculate? See, this is the system, that is a P is a point. P is a point. It is consist of number of electric potentials. This is called electric potentials. Away, the P is a point. That is the number of charges is, that is a Q1 is the charge. Q1 is a charge. Q2 is the charge, and Q3 is the charge, and Q4 is the charge. That is the number of charges is acting at a pointing single point. That point is called equilibrium position. Equilibrium position. The Q1, Q2, Q3, Q4 is the number of charges is acting at a point at a P. The distance of P1 and P is that is taken as R1, that is R2, that is R3, that is R4. That is the R1, R2, R3 is the distance between the at a point P to single point charges. Single point charges. That is the system. That is the diagram of the by using the system of electric potential. Consider the Q1, Q2, Q3 and Qnth, that is nth term. Okay, that is a Qn is the nth term. Rn is the nth distance of a charge. Q1, Q2, Q3 with the number of point charges is placed at a distances R1, R2, R3, Rn respectively. First to find the electric potential at a point P due to the charge is Q1. First write, that is the electric potential. The electric potential due to at a point P due to the charge is Q1. Charge is Q1. What is the equation? That is electric potential is V1 is equal to constant is same 1 by 4 epsilon naught. The single point charge is Q1. The distance is R1. Similarly, the electric potential V2. The electric potential V2 at a point P due to the charge is Q2. Due to the charge is Q2. What is the equation? That is V2 is equal to 1 by 4 5 epsilon naught Q2 by R2. Q2 by R2. Again similarly, V3, how to find V3? That is V3, the electric potential V3 at a point P due to the charge is Q3. Charge is Q3. What is the equation? That is V3 is equal to, that is 1 by 4 5 epsilon naught Q3 by R3. That is called equation number 1, equation number 2 and equation number 3. V1, V2, V3 is the electric potential at a point P due to the first charge, the electric potential V2 at a point P due to the second charge, and the electric potential V3 at a point P due to the charge is Q3. Then after the V1, V2, V3 by using a superposition principle. By using a superposition principle. What is the principle of the, what is the statement of superposition principle in this diagram? The total electric potential must be is equal to sum of the individual, that is a Vn, sum of the individual electric potentials. Therefore, the electric potential, the total electric potential V is equal to, what is the V1? That is a 1 by 4 5 epsilon naught Q1 by R1. What is V2? 1 by 4 5 epsilon naught Q2 by R2 plus what is V3? 1 by 4 5 epsilon naught Q3 by R3, so on. Next, fourth term, fifth term, ending is the nth term. Therefore, the total electric potential V is equal, what is the common factor? 1 by 4 5 epsilon naught, 1 by 4 5 epsilon naught, 1 by 4 5 epsilon naught. That is the common factor. 1 by 4 5 epsilon naught is the common factor. Then bracket open, the sum of the reciprocal product of the sum of these charges and reciprocal of distances, the r1 q1 by r1 q2 by r2 plus q3 by r3. The nth term is qn by rn, qn by rn. Then the total electric potential, the constant is outside, the sum of the charges reciprocal of distances by using a summation I is equal to 1 to nth term, first term to nth term, that is the charge is, the last term is qn, the distance is nth term is rn. This is the electric potential, total electric potential. Total electric potential, by using a superposition principle, find the electric potential. Once again, the superposition principle means the total electric potential must be is equal to sum of the individual potentials. The system, first draw the system. The system is consist of number of charges q1, q2, q3, q4 is the number of charges is acting at a point in P. r1, r2, r3, rb the distance of the each charge. First to find the electric potential at a point B due to the q1. That is called first equation. The electric potential at a point B due to the second charge, that is second equation. And the electric potential V3 at a point P due to the charge is Q3, that is V1, V2, V3. By using a superposition principle, V is equal to sum of the potentials. The constant is take outside, that is the, by using a bracket, the sum of the charges, individual charges, and the reciprocal of the distances. The nth term is q1 rn. Finally, we will get V is equal to 1 by 4 pi epsilon naught by sum of the means by using a summation first term to nth term, that is q1 by rn. This is the concept of superposition principle, by finding the electric potential by using a superposition principle. Superposition principle. Next concept is equipotential surface. Equipotential surface. What is the meaning of equipotential surface? How to draw the presence of electric field lines? How to draw the equipotential surfaces? And what is the properties of equipotential surfaces? The equipotential surface means, see, that is the one surface, that is the surface having the same electric potential at every point, any point, is the electric potential. This is called electric potential. This is called electric potential. The electric potential is same at any position of the surface. The electric potential is same at any position of a given surface is called equipotential surface. What is the example of equipotential surface? The surface of a charged body of any shape. The better example is, that is the surface of a charged body of any shape. That is the example of equipotential surface. Then what is how to draw the equipotential surface for in a point charge? First, the equipotential point, how to draw the equipotential surfaces? First, how to draw the equipotential surface of positive charges? First, to draw the positive charge, draw the electric field lines. That is a positive means it is a outward direction. The positive means the diverging, that means diverging, there is a single isolated point charge. Draw the surface. The dot mark is consist of a surface. The dot mark is, it is consist of surface. That is the equipotential surface of positive charge. Equipotential surface of positive charge. And negative charge, how to draw? That is draw the negative charge. negative. Draw the electric field lines. The negative means it is a converging, and converging. It is a electric field line due to the negative charge. The surface is present. The dot mark is consist of equipotential surface. That is the equipotential surface of a negative charge. Equipotential surface of a negative charge. Negative charge. Next, how to draw the equipotential surface for dipole? Dipole, equipotential surface for dipole. Dipole means it is consist of positive and negative charge. It consists of positive and negative charge. First, to draw the one positive charge and negative charge. Draw the electric field lines. That is electric field lines. Electric field lines. It is a direction of the positive means outward direction, outward direction, outward direction. Negative means converging, converging, converging. Converging, converging, converging. Draw the equipotential surface of positive charge. Positive charge. This is called equipotential surface of dipole. That is one more surface. One more surface. That is the diagram of the two equal and opposite charges of equipotential surface. That is also called equipotential surface of a dipole system. Dipole system. And draw the equipotential surface of pair of equal and positive charges. Pair of equal and positive charges. What's positive charges? That is a draw the positive charge and positive charge. It is a draw the electric field lines. That is called electric field lines. That is a surface. Sorry, not that is positive positives. It does not intersect to each other. Positive charge, positive charge. One positive charge is that is a diverging direction. Diverging, diverging, diverging. That is also diverging, 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 diverging. Diverging and diverging. Draw the equipotential surface of. Draw the equipotential surface. That is the equipotential surface and equipotential surface. Equipotential surface. The equipotential surface means what? The potential, the electric potential at every point. That means the surface having the same electric potential at every point is called equipotential surface. This is the diagrams of equipotential surface of positive charge, equipotential surface of negative charge. It is a equipotential surface of positive, negative. That is a pair of positive and negative. Equal. That is positive and negative or dipole system. Dipole equipotential surface of a dipole system. It is a pair of equal positive charges. Negative means it is a converging. That means pair of negative charges. That is the statement and diagrams of a equipotential surfaces. What is the properties? First, what is the properties of equipotential surfaces? Properties, that is also important. 2 mark and 2 mark question is important. This diagram is 1 mark questions is important. That is the question is draw the equipotential surface of a dipole system. This type question is important. Next, properties. Write the any two properties of equipotential surface. That is a 2 mark question is 2 and 3 mark question is important. First property, see the diagram shows this is a positive charge, this is negative charge. The two equipotential surface, that is the one equipotential surface, this is called one more equipotential surface. The two equipotential surfaces does not contact each other, does not intersect to each other. That is the first property. If the two equipotential surfaces does not contact to or does not intersect to each other, that is the one property. Second property is the work done is zero. The work is zero in a moving test charge over the equipotential surface. That is the second point.